So this is your lab activity today, and for this the apparatus required are target material on which we will fall the light, and we need a light source from where we will fall the light to the target material, and that target material is actually a photosensitive plate. So because that means it will affect when a light falls on it. So this is a photosensitive plate, which is the target material that we use, and different target material that we have in the simulation link. You can select those material because every different metal has its own work function. Because in that metals, we know electrons are present. So those electrons are bound to the that metal surface with some binding energy. So that is exactly the work function of the metal. So how much, with how much energy they are bound to the metals, so that much energy is required to eject the electrons. So if you are giving the light which has having the energy which is greater than that binding energy, so ejection of electron will take place. So after that photoelectric effect will be there. Okay, to have the photoelectric effect, so minimum that much energy is required, because if you are giving the light which is having the lesser energy than the work function, so no electron will be ejected, no photoelectric effect will be seen. So photoelectric effect will be only there when a minimum amount of that much energy is given to the metal surface, so ejection of electron will take place. So we need a target material, we need the light source. Using that light we can have the photoelectric effect, and we can vary the intensity of that light. Okay, and we can vary the frequency of that light. That means we can change the color of light. So different light that you can use using the light source. And we need a voltmeter from where we will apply the potential to that tube. And we will need a ammeter through which we will find how much photocurrent is coming when electrons are being ejected due to the photoelectric effect. So connecting wires are needed. So these are the apparatus required to perform the experiment. And you see, this is a photoelectric effect. And when a suitable frequency of light, you can see from this figure here, when a suitable frequency of light falls on the metal, so ejection of electron takes place. So that means suitable frequency of light means because electrons are bound to the metal, because we know that in metal consists of electrons, and but those electrons are inside the metals and they are not free to move outside the surface of those metals. So that means they are bound to the metals with some binding energy. So when light is coming, so if this light has energy such that it is greater than the binding energy of that electron, so then electron will be ejected. If suppose you are falling the light with energy 4 electron volts, okay, and the binding energy of this metal surface is 5 electron volt. So that means this work function of the metal is 5 volt, and you are falling the light with the energy 4 electron volts. So that means what will happen? No ejection of electron will take place, because electrons are bound with the 5 electron volt and you are falling the light with 4 electron volts. So no ejection of electron will take place. So no photoelectric effect will be seen when this energy is less than the work function of that metal. So what happens when you are increasing the energy? That means if you increase energy from 4 to 5 now, work function is still 5. So you are giving the 5 electron volt energy using the electromagnetic radiations. So that means electrons having the minimum energy that you have given, so electron will be ejected. But those electrons will be at rest, because all energy is used to compensate the binding energy. So no energy will be given to the electrons. So those electrons will be at rest. So what happens when you give even more energy? That means if you are giving 6 electron volt energy, and 5 electron volt energy is required by the work function. Okay, so that means the rest of 1 electron volt. So what will happen to the that rest of 1 electron volt? So that energy is converted to the kinetic energy of electrons. That means those electrons which are being ejected, they have kinetic energy, they are moving. So if they form the photoelectric effect, when these electrons are coming, so they are moving, so they can reach to the cathode or reach to the electrodes without any voltage. So due to the photoelectric effect, we have not, if you are not applying any voltage to the electrodes, but you are only following the light, So by falling the light, and that light has energy which is greater than the work function, so still those electrons are reaching to the electrodes and constitute the current. As we fall the light on the metal surface and these electrons are bound to the metal surface, so when this light which is coming having the energy which is greater than the binding energy of this electron, which is greater than the work function of this metal surface, so then these electron will be ejected. So only then photoelectric effect will be seen. And as you will increase the energy of this light, so what will happen, more and more kinetic energy of electron you will get. And but what happen when you increase the intensity of light? So what the meaning of increase in intensity of light? Increase in intensity of light means you are increasing the number of photons. If suppose in this figure here, you can see 3 photons are coming and 3 photons will be ejected. So you can see 2 electrons are outside and one with the arrow, it is still in the surface, and it will be ejected because 3 photons are coming and 3 photons having the energy which is greater than the binding energy. So these 3 electrons will be ejected. But as you will increase the intensity of light, means you are not changing the color. Okay, because you are having the yellow light only and you are increasing the intensity, means you are increasing the number of yellow photons. So if more photons will come and strike to this metal surface, and if they have the energy greater than the binding energy, so as many number of electrons will be ejected. So if 10 electrons will come, so 10 photoelectrons will be ejected. When the increase in the intensity means number of photoelectrons will increase, but all those electrons have same kinetic energy, because you see we have not changed the energy of light now, because we are not changing the frequency of light. So if you are not changing the frequency or you are not changing the wavelength of light, so that means the kinetic energy those electron will gain, it is the same, because when you are increasing the number of photons will increase the number of photoelectrons, so that will increase the current, but kinetic energy is same. These are the connecting wires that we need to make the circuit diagram, and we are using the voltmeter and the ammeter to make the circuit. So now we will study about the theory behind this experiment, because we know that this photoelectric effect is instantaneous phenomena. That means as you will fall the light, you will get the current. Okay, it is not that after certain time or time lag is there to have this photoelectric effect. This is instantaneous. As you will stop the light, no photocurrent you will get on. And when you are increasing the number of photons, you are increasing the intensity of light, it is increasing the current, photocurrent, but kinetic energy of electrons is same. But when you are changing the color, if suppose you are changing the color and you are increasing the energy, so that means when you are increasing the frequency, so binding energy is same, 5 electron is same, but when you are increasing the energy means more kinetic energy of electrons will be ejected. It is energy is directly related to the kinetic energy of electrons. Now you can see these are the equations that we need to explain the photoelectric effect. And you see, if you have a frequency nu naught, which is the threshold frequency which is required to fall on the metal surface to have photoelectric effect. This is related to the work function of the metal. So W is actually the work function of the metal, and we are taking this work function equal to h nu naught in terms of the energy, or you can say in terms of the frequency. Okay, so this is the minimum frequency which is required to have photoelectric effect. And if you are giving more energy to the light, so if you are giving more than this work function, so that means rest of the energy will be converted into the kinetic energy of those electrons. So you can see that this kinetic energy, that is equal to the difference between what you are falling minus the work function of that metal surface. So that means rest of the energy is converted into the kinetic energy of electrons. So if suppose some electrons are coming, you are following the light of 7 electron volt, and you have the work function of 5 electron volt. So 2 electron volt is the kinetic energy. So if electrons are coming with 2 electron volt and you want to stop them, So how much energy that is required to stop them? If suppose 2 electron volts are coming, and so minimum 2 electron volt energy is required to stop them. Now I will stop sharing this. I will share you my simulation link, and where we will explain these equations. So here you can see that we have a target material in this discharge tube, and we have a cathode, and there is a window from where we fall the light on this target material. So this target material is actually a photosensitive plate. So when light of suitable frequency comes and strike to this metal surface, and light has energy which is greater than the work function of this metal, so that means the greater than the binding energy of electrons, so those electrons will be ejected. So electrons are ejected, as many numbers of photons are striking, similar number of electron will be ejected. 10 photons are coming and striking the metal surface, so 10 photoelectrons will be ejected. If we are following the light, electrons are coming, and if this light has sufficient energy, then it is greater than the work function of that metal, so those electrons are moving and they will reach as the cathode. And we are making the circuit diagram here, and we know that we connect the ammeter in series connection, and we connect the voltmeter in the parallel connection to what voltage you can apply to the discharge tube, and to note down the current in this circuit. So you see, if you are not applying any voltage to this discharge tube, 0 volt we have given, we are just following the light on it. So these electrons will be ejected and they will reach at the cathode. So they are reaching at the cathode. So you can see from the when they will flow through these wires, so ammeter will show you the current. So these are the photoelectrons which are being ejected due to the photoelectric effect, because we are not given any voltage. Because if you want to move the charges, you have to give the voltage. So if you are not giving the voltage, but you are only following the light, so you are getting the current because electrons are moving. So that means at 0 voltage, you will get some current. And in this experiment, what we will do, we will give the voltage in reverse way. That means in the reverse biasing case, you will apply the voltage. So because the electrons are, if suppose electrons are going in positive extraction, and you are applying this reverse potential in negative extraction, that means electrons are going in extraction, and you are applying this voltage in the minus extraction. If those electrons are coming with 2 electron volt, and if you are giving this voltage that is equal to minus 2 electron volt, so what will happen, this current will become 0. Okay, that means if you are applying negative, you can see from this battery here, we are applying negative voltage to this cathode, and we are applying this positive voltage to the this target material here. So what will happen, firstly there was 0 volt and current was coming. Now we are giving the voltage in reverse potential we are applying. When you are applying the negative voltage, so what will happen, these electrons will get the repulsion. Okay, so due to negative, electrons are negative charge and you are still applying the negative potential, so negative repulsion will be there, so less number of electron will reach. Your current will start decreasing. So as your current will start decreasing and you are still increasing the reverse potential, where this current is becoming 0. So current is becoming 0, no electron will reach at the cathode now. So this is what the stopping potential. Stopping potential means, because current is becoming 0 means electrons are now stopped. They are at rest now. The stopping potential is a potential to stop the electrons inside the discharge tube, because this light is coming, and from the light electrons are ejected. They have the kinetic energy. They are moving. So to make electrons at rest or to stop them inside the discharge tube, we are applying reverse potential to it. Now here you can see that these are the different metals you can have, and each metal has its own work function. So if you have a metal and electrons are inside it, so they are bound to those metals only. Okay, so that means they are bound with some work function, bound with some energy, binding energy. So if you are giving, if suppose you are taking metal as platinum, so you can see your work function is 6.4 electron volt for platinum metal. So when you are following the light, and this light has energy which is greater than the 6.4. Okay, if suppose you are following the light of 8 electron volt, so 6.4 electron volt is used for the work function to that for the binding energy of electrons. The rest of energy, that is 1.6, here you are following 8 electron volt, so rest is 1.6 electron volt. So rest 1.6 electron volt is the kinetic energy of electrons. From here you can see this is equation number 1, which is W equal to h nu naught. H nu naught is equal is the work function of the metal, so minimum this much energy is required. 6.4 energy is required when we are using the platinum. Okay, when you are giving more energy, and when you are giving more energy, so excess energies will be given to the electrons in terms of the kinetic energy. If suppose you have given 8 electron volt, so 6.4 is used as work function. That means electrons which are coming as a photoelectrons due to the photoelectric effect, they are moving, they are having the kinetic energy. So this is the equation number 2. It is actually the Einstein photoelectric equation, which is given by Einstein. And so, but when we are changing the frequency of light, so when you are increasing the frequency of light, you are increasing the energy. So from this expression, you can see here from when we are putting this value of W equal to h nu naught, and you can see this kinetic energy maximum will become equal to h nu naught, h nu minus h nu naught. So as you will increase the frequency, from this equation you can see, as you will increase the frequency, kinetic energy will increase. So that means the electrons which are coming, they have the high kinetic energy. So if they are coming with the high kinetic energy, so more stopping potential will be required to stop them, because firstly electrons are coming with 2 electron volt, so you have to apply 2 electron volt to stop them. When they are coming with the 5 electron volt, so you have to give the energy 5 electron volt to stop them. So what energy you are providing, so that energy you are providing in terms of the potential, so you are applying the potential, so that will give the energy. As this kinetic energy of electron will increase, you need to have more stopping potential to stop them. This stopping potential is depending only on the frequency, and it is not depending upon the intensity of light. So from there you can see this is a graph here. So you see, if you have the frequency 1, and you see at 0 volt there is some current, so that is due to the photoelectric effect. And when you will increase the reverse potential, so you are increasing the negative potential, so less electron will reach due to the repulsion. So you can see that this current will start decreasing, and it will become 0 at certain point, and this is the value which is named as the stopping potential. So where all the electrons stopped inside the discharge tube, they are not reaching at the cathode. If suppose you decrease the frequency, that is frequency 2, and if you are decreasing the frequency, that means you are decreasing the energy. So if you are decreasing the energy, so that means the electrons which will come, they have the less kinetic energy. So if they are coming with less kinetic energy, so less stopping potential will be required to stop them. You will get the graph at less stopping potential. And when you still decreasing the frequency, your stopping potential will decrease. They are coming with the same current, because we are changing the frequency, and if suppose you are changing the intensity of light now. Okay, you are not changing the frequency now, you are changing the intensity. If suppose you have the red light, now you are increasing the intensity, means red intensity is increased, means red photons are increasing. So if red photons are increasing, so more number of red photons we have, so more number of photoelectrons will be ejected. So if more number of photoelectrons are coming, all these photoelectrons have same energy, those electrons will be stopped with the same stopping potential. That means with the stopping potential is not depending upon the intensity of light, but the stopping potential will depend upon the frequency of light. So you can see here that we can select the material. We have different materials: copper, sodium, zinc, platinum. So different material that we have, this is the target material on which we will fall the light. So this is the light source. from we are falling the light on this photosensitive plate, and you have also option of the area of plate. So if you are increasing the area, so obviously your current will change, because your light is falling over the more area, so more photoelectrons will be ejected, so more current you will get in the circuit. So we have the ammeter and the voltmeter to note down the value of current and what voltage we are applying to this tube. For that, now I have to switch on the light. If I have clicked on this switch on the light, so you can say light is coming from this light source, and it will go to this discharge tube where we have made the photosensitive plate as anode, and cathode we have. So, and to make the circuit to have the current, we are taking this ammeter in the series connection, and we are taking this voltmeter in the parallel connection. So now you can see we have not applied any voltage. You can see from this voltmeter, this voltage is 0. And this area of plate I have selected 0.1 centimeters. You can take any area. So you see area of plate I have selected 0.1 centimeter square, and you have option that you can change the intensity of light. And this is the wavelength of light that you can select. Suppose I have selected 100 nanometer. So I have chosen copper material. Area of plate I have selected this 0.1 centimeter square. Intensity I have selected 5 watt per meter square, and wavelength I have selected 100 nanometer. So now we have to plot the VI characteristics. Okay, but in this case, you see your voltage applied, it is showing here 0 volt. So that, and your slider is at maximum point here. So at maximum point here, it is showing you 0, because we are applying here the reverse potential. That means in the negative direction. So that's why they have made in this way. By choosing these variables, what you will do now, you will increase the voltage. Firstly, see at 0 volt, you have some current. So that means this is a photo current. So how we are getting? Due to photoelectric effect. We have not applied any voltage, but you are getting the current. So that means electrons are coming, charges are coming. When we are falling the light, photoelectrons will be emitted. So they have some kinetic energy. So they will reach at the cathode. So they are giving the current at 0 volt. But now you see when we will increase the voltage. If I am increasing the voltage, you can see your current starts decreasing, because I am now applying negative voltage. So firstly, more number of electrons have reached the cathode. Now I am applying reverse potential. So that means they are getting the repulsion and they will not reach. So you can see that at 7.7 volt, it is showing you 0.01. And now I am increasing this this value at 7.8. So it is showing you 0. So this is the stopping potential. And in this experiment, we are finding this stopping potential. And you see, I have applied 5 watt per meter square. The wavelength I have used 100 nanometer. For that, I have seen this stopping potential is 7.8. And in this experiment, you will change the intensity of light, keeping your wavelength constant. You have to make the observation table like this. You are firstly you will make the VI characteristics for one intensity, then make the VI characteristics for change with the change of intensity, but your wavelength should be fixed. Take wavelength fixed and change the intensity of light and see what value there is a change in the value of this stopping potential. Suppose I have changed this intensity to 5 to 10 now. If I am changing my intensity, wavelength I am not changed, I will make again the VI characteristics, then start from 0. You see, firstly at 5 volt per meter square, you can see your current is 3.86. But now as I am increasing the intensity, means increasing the number of photons, more number of electrons will be ejected. So more number of electrons are reaching at the cathode. So that means more current you will have. But you will see your stopping potential is not depending upon the intensity. That means as you will increase the voltage, you see it will become 0 at same. It will become 0 at same stopping potential. Now you can see that this stopping potential is not depending upon the intensity of light here.